So welcome to lesson 5. In this lesson, we're essentially going to look at powers with rational exponents. Rational is just a fancy way of saying fractions. So we've seen these definitions of powers before. We said that there are 3 definitions of powers. We looked at 2 of them. We're going to look at the third one today. So the first one we said was 0 as an exponent. Anything to the power of 0 will equal 1, except for 0 to the power of 0. Then we looked at the definition with negative exponents. So essentially, whenever you have a power with a negative exponent, we can always rewrite it to have a positive exponent. So in this case, we would rewrite it so that it's a fraction. The 1 is always the numerator, and the denominator is essentially this, but the exponent has become positive. And then we have our third rule, and that's the rule we're going to learn today. Ignore all this whiteout. I just made a mistake, so we're just started refilming again. So in general, when n is equal to or greater than 0, the rule is this will equal this. Okay? This allows us to convert an expression in radical form to an expression in exponential form and vice versa. So what do we actually see here? We've seen these before. We saw this a couple of lessons ago. We called them radicals. So here we have a radical. In the past, we only looked at square roots, but recently we've been changing the index. So if that's a 3, we know we have a cube root. If that's a 4, we have the 4th root. So whenever you have a radical, you don't need to keep it as a radical. We can always convert these radicals to powers. When we do that, we can see that the number underneath the radical sign becomes the base, and the exponent is always 1 divided by n, where n is the index number. So let's take a look at some examples on how to convert this. So example, we have 9 to the power of half. We have something in exponential form. Let's convert it to radical form. So we can see here that the base here is 9, and the base here becomes the value underneath the radical sign. So underneath the radical sign, we'll have 9. And we also see that the exponent is 1 over n, where n, or here 2, represents the index. So 9 to the power of half is the same thing as saying the square root of 9, which we know is 3. Let's take a look here again. We have something in exponential form where the where the exponent is a fraction in the form 1 over n. So we're going to rewrite this as a radical. So I'm just going to write the radical sign. Again, the base becomes the value underneath the radical, and the denominator of the exponent becomes the index. So here we're trying to find the cube root of 64. Again, that just means what number cubed will give us 64. We know that that's 4. 4 cubed is 64. Again, today I'm going to assume that you've practiced a lot of things. You've practiced your radicals so that you know some of these numbers. Again, you should be getting more familiar or comfortable with them. So write each of the following in exponential form. So in this case, they gave us the expression in radical form. We're going to convert it to exponential form. So from here, we see that the value underneath the radical sign becomes the base. So here the base will be 14. The exponent will always be 1 divided by n. So 1 divided by n, where n is the index, the number above the root here, or the radical sign here. Remember I said if we don't write it down, there is an imaginary 2 there. So we write 14 to the power of half. So whether we say square root 14 or 14 to the power of half, they mean the exact same thing. Let's take a look here. Again, we have something in radical form. We want to convert it to exponential. The number underneath the radical becomes the base. So here 5 is the base. And the exponent is 1 over n, where n is the radical, which is 3. So this means find the cube root of 5. But this also means find the cube root of 5. Here it looks a bit complicated, but let's just follow the exact same rules. So we know that the value underneath this radical sign becomes the base. So I know my base here is negative 6 to the power of 3. I know that's the power in itself, but we're going to treat that as the base. And that's going to be put, because that's the base, to the power of 1 over n, the index number 5. So we have negative 6 to the power of 3, and all of that to the power of 1/5. We see here that we have a power being raised to an exponent. We know that that just means we can keep the base and multiply the exponents. So this is the same thing as saying negative 6 to the power of 3/5. This is similar. Let's take a look. There's a negative here, which I'm not really worried about right now. So let's just keep it on the side and let's deal with this. When I deal with this, again, I have something in brackets to the power of 3. So let's keep it in brackets because I'm going to convert this to exponential form. So if I take a look at my radical form, again, the number underneath the radical becomes my base. And that's raised to an exponent of 1 over n, where n is the index value. So the 9th root of 117 can also be written as 117 to the power of 1 over 9. And I'm going to copy this 3 because I haven't done anything with it. I can still simplify because, again, I have a power being raised to an exponent. So I have negative 117 to the power of 1 over 9 times 3. So 1 over 9 times 3 is equal to, again, I can simplify this. I can divide both of these by 3 to give me 1 over 3. So this is the same thing as saying negative 117 or 117 to the power of 1/3. I hope that's been clear. Okay, so again, when you're going from radical to exponential, all you do is copy whatever's underneath the radical as your base. Then you take the index and put your exponent as 1 divided by the index. Here it was 2, so 1 over 2. Here it was 3, so it was 1 over 3. We also need to know how to work backwards. So if we're given something in exponential form, you should be able to write it in radical form as well. So in this case, again, the base for the exponential form becomes the value underneath the radical. So in this case, underneath the radical, we have a 12. And the denominator of the exponent becomes the index, so that becomes 2. You should note that you can only do this. The denominator can only become the index if the numerator is 1, because that's the rule we see here. The exponent must have a base, the power must have a base, and the exponent must be 1 over the index. Here is 1 over 2, so the index is 2. Taking a look here, again, the base becomes the value underneath the radical. Don't forget that you need to know how to find the base. Here, the negative 9 isn't within a bracket. It should be rewritten as negative 9 as the base to the power of 1/4. So we know that the value underneath the radical sign will be 9. My exponent is in the form 1 over n, so 1 over 4. So 4 becomes my new index. So I've rewritten 9 to the power of 1/4 as the 4th root of 9. And there's a negative up front, which I haven't done anything to, so I'm just going to copy the negative. Let's try this one. Again, the base becomes the value underneath the radical. The negative is within brackets here, so we know that the base, or the value underneath the radical, is negative 10. The exponent is in the form 1 over 7, which is great because we want it in the form 1 over n, or the index. Here the index is 7, so we're going to write 7 as our index. Taking a look at this last example, we have negative 13 to the power of 4 over 5. Okay, so here we kind of run into some sort of trouble because if we compare this form to here, we have a base, that's fine, but our exponent isn't in the form 1 over n. Now this can pose a problem, okay? So what we are going to do then is we are going to separate out the exponent. Just like how here, we eventually got negative 6 to the power of 3, all to the power 1/5, and then we multiplied it to put it together. Now we're just going to separate it out. So if I separate it out, I'll have negative 13 to the power of 4, all to the power of 1/5. Why does this work? Because I have a power being raised to an exponent. If I multiply these exponents, 4 times 1/5 gives me 4/5. So this is equivalent to this. And now I can rewrite this as a radical. Because my new base now, I have a base, which is fine, base according to this. And my exponent is now written as 1/n, in this case 1/5. So I'll put my base underneath the radical sign. And I know my n value here is 5, and that will be my index over here. Okay, we'll do more of these. So if you're a bit confused now, we'll do more of these so that you get the hang of it. But you should note that when you have something like 4/5 as your exponent, you can split it because this is the same thing as saying negative 13 to the power of 4, all to the power of 1/5. When you have a base to a power to another, being raised to another exponent, you can multiply the exponent, which gives you the original expression. So this is just converting back and forth, going from radicals to exponential form and back. What you need to be able to do also is to solve these, evaluate them. So we've seen these power tables before. I gave it to you earlier when we were learning radicals, and I said you should become more and more familiar with this, and I hope that you are. Okay, so for a couple of these, we're going to rewrite them as radicals, and then eventually I want to wean off from that. I want you to eventually become more comfortable looking at the question where it's an exponent with a fraction exponent, it's a power with a fraction exponent, and you know exactly how to solve it. So 81 to the power of half may mean nothing to you right now, but if you don't know what to do with it, convert it to its radical form. So in this case, the base becomes the value underneath the radical sign, and my exponent is 1/n, so the n becomes my index. This is the same thing as saying, what is the square root of 81? In other words, what number squared gives me 81? Well, we know the answer is 9. Here, I converted this to this and went to 9, but in reality, you should be comfortable going from here straight to 9. Again, I've given you this as guidelines, but you should eventually become super familiar with all of this so that you can do it in your head. Similarly here, we have 125 to the power of 1/3. If we rewrote this, it would be the radical sign 125. And because it's in the form, the exponent is in the form 1/n, the 3 becomes my index. So what's the cubed root of 125? In other words, what number cubed gives me 125? The answer is 5. If you aren't recognizing patterns or this is hard for you to kind of learn, just keep in mind that whenever you have a fraction exponent, all your answers are usually going to be between 1 to 6. The exception is if it's a square root, because I expect you to know those square roots. So if you are confused and you're like, I don't know what the cube root of 125 is, start from 1 and go high and go up. So 1 cubed is just 1. That's not the answer. 2 cubed is 8. 3 cubed, 27. 4 cubed, 64. 5 cubed, 125. So you know 5 is the answer. So let's try that again, but without converting it to radical form this time. So here, this was the same thing as saying, what is the cube root of 125? This is the same thing as saying, what is the 5th root of 243? So if I had to rewrite it, it would look like this, where the base becomes the value underneath the radical, and the n value is 5. So what's the 5th root of 243? Again, if you don't know it off the top of your head, start from 1 and go higher. So 1 to the power 5 is just 1. 2 to the power 5 is 32. 3 to the power 5 is 243. The answer is 3. Again, if you're like, how is he just coming up with these numbers? It's practice. You need to practice these more so that you start recognizing these patterns. Now, it works great, as we've seen, when the exponent is 1 over n, because that's the definition. We can easily convert that into a radical. It gets a bit more tricky when you have 36 to the power of 3 over 2. Based on the definition, we always want our exponent to be 1 over something. So just like in this example where we had to break apart the exponent, we're going to do the same thing here. Now, the rule that you're going to use most of the time is just break away the numerator. So what do I mean by that? Let's keep the base here, which is 36. 3 over 2 can be rewritten as half times 3. So notice I just broke the numerator away and copied the rest. So the 3 became here, or a 3 I moved here, and we were left with half. So half times 3 is the same thing as 3 over 2. And that's the order I want to write it in. I'm going to have 36 to the power of half, and all of this to the power of 3. Why does this work? Because now I have a power that is being raised to an exponent, which means I can multiply the exponents, which would give me 36 to the power of 3 over 2. Now, 36 to the power of half, we're gonna start working with these in our head. So half just means square root of 36, which is 6. And 6 to the power of 3 then is 216. Again, these are numbers you should become more familiar with. Let's break this apart. Again, we're going to copy down the 64. We're breaking apart the numerator. So let's copy. So the top will be 1 over 3. And then we broke apart the numerator again. 1/3 times 2 will give me 2/3. I'll keep the base of 64 so we know these are equivalent. So instead of converting this to a radical, let's name it as is. The n value, the index is 3, so I'm looking for the cubed root of 64. What to the power of 3 will give me 64? Well, the answer is 4. And because the square is there, I'll do that at the end. So 4 squared is 16. Let's try this one here. Again, I'm going to break apart the numerator to convert it. So I'm going to copy the 1 over 2 and put that to the exponent of 5 again. 5 times half is 5 halves. Here I have 100 and my n value is 2, so I'm looking for the square root of 100, which I know is just 10. And 10 to the power of 5. Remember, when you have 10, you write the 1 to the, when you have 10 to the power of something, you write the 1 and you copy down this many zeros. So 1, 2, 3, 4, 5. Okay, so give me 2 seconds as I switch over to the next page. Okay, we're going to keep going, and these look a bit more complicated because now our bases are fractions as well as our exponents, but it works in the same way. Here we have 16 over 81 to the power of 1/4. So based on our exponent laws, we know that this is the same thing as 16 to the power of 1/4 divided by 81 to the power of 1/4. In other words, the exponent was 1 here and 1 here, and we're raising our powers to an exponent. So we multiplied 1 by 1/4 to give 1/4 here, and 1 by 1/4 to give 1/4 there. Let's read it as is. Again, because the index, the n value is 4, I'm looking for the 4th root of 16. So something to the power of 4 gives me 16, which is 2. And here I also have 4, so I'm looking for the 4th root of 81. Something to the power of 4 gives me 81. And the answer is 3. Let's take a look here. So here I have -8 over 27 to the power of 1/3. This negative applies to this entire fraction. When you're breaking it down, you either associate it with the numerator or the denominator. So in this case, I'm going to associate it with the numerator. So at the top, I have -8 to the power of 1/3, and the denominator is 27 to the power of 1/3. Again, we're following the same rules we did here. Essentially, we're using the power laws to essentially say there was an exponent of 1 here and 1 here. We're multiplying the exponents out because we have a power being raised to an exponent. Now, same thing. Here, the n value is 3. So we're looking for the cube root of -8. So something to the power of 3 gives us -8. So let's just ignore the negative for now. We know that 2 to the power of 3 gives us 8. We have to choose whether we put a negative or a positive. And this is where you might want to write it out in your head or on the piece of paper. So you're trying to say -2 to the power of 3, which is the same thing as -2 times -2 times -2. We know 2 times 2 times 2 is 8. Negative times negative is positive, times negative is negative. So we know that -2 is in fact the cube root of -8. We're also looking for the cube root of 27, which is just 3, because 3 to the power of 3 is 27. Moving on to this, again, we have a scenario where we don't really like our fraction here because we always want it in terms of 1 over something. So we're going to use that same trick we used previously. We're going to slide over the numerator. So we have 25 over 49. I'm going to keep the half first, and I'm going to slide over the numerator. So now I have 25 over 49 to the power of half, all to the power of 3. Again, if I multiply these exponents, it'll give me 3 over 2, so I know I'm correct. Here, this half will be, this half applies to 25 and 49 individually. So this is the same thing as saying 25 to the power of half divided by 49 to the power of half, all to the power of 3. Because the n, the index value here is 2, I'm looking for the square root of 25, which is just 5. I'm looking for the square root of 49, which is 7. And all of that is to the power of 3. Again, numbers you should be familiar with. 5 to the power of 3 is just 125. And 7 to the power of 3, 343. I'm going to keep going. They're getting slightly harder. So now I have 64 divided by 125 to the power of -2 over 3. There's a couple of things I can do here. Here I have a fraction being raised to a negative exponent. So remember, this is the perfect reason to use the flip it rule. With the flip it, I'm going to flip the numerator and denominator. So it'll give me 125 over 64. And when I flip it, the exponent becomes positive. It's slightly easier now because I have a positive exponent, but again, the exponent is a fraction and it's not in the form 1 over something, so I'm going to have to slide over the numerator. So I have 125 over 64 to the power of 1/3, and I'm going to slide over the numerator, which is 2. Again, we have a fraction. This 1 over 3 applies to both of these numbers. So 125 to the power of 1/3 over 64 to the power of 1/3, all to the power of 2. And so we're here, because the index is 3, we're looking for the cube root of 125. So something cubed gives me 125, that's 5. Here we're looking for the cube root of 64. Something cubed gives me 64, which is 4. And all of this is to the power of 2. So 5 squared is 25, and 4 squared is 16. We have one last example before we move on to slightly different questions. So here we have 16 over 81 to the power of -3 over 4. Again, we have a fraction to a negative exponent. Let's start with the flip it rule. So we have 81 over 16 to the power of positive 3 over 4. Again, the exponent is a fraction, but it's not in the form 1 over something. So we're going to slide over the numerator. So I'm going to keep the denominator and slide over the numerator. I'm not going to write this extra step where I take that exponent and apply to all of these individual numbers. You should do that in your head. So here at the numerator is what is the fourth root of 81. So something to the power of 4 gives me 81. The answer is 3. And the bottom, we're looking for the fourth root of 16. Something to the power of 4 gives me 16, which is 2. And all of this is put to the power of 3. So 3 to the power of 3 is 27, and 2 to the power of 3 is 8. Okay, so what we've seen here is you don't, even though it's good to know how to convert from radical to exponential and exponential to radical, you should be able to look at the exponential and automatically know what radical is associated with it. So when we had something like 16 to the power of 1 over 4, you're essentially asking yourself, what is the fourth, the index, the n value, what's the fourth root of 16? And then you continue to solve it in that manner. So here it says, write each expression as a single power with positive exponents. So what we see here is we have a whole bunch of 7s as our bases and a whole bunch of fraction exponents. We're just following the power laws here, but they look slightly more complicated because obviously we're dealing with fractions. So let's take a look here. Here we have 7 to the power of negative 2 over 3 times 7 to the power of half divided by 7 to the power of 1 over 6. So if I was to simplify this using the power laws, I'm multiplying two powers with the same base. So I'm going to keep the base and add the exponents. Then I'm going to divide this answer by this power. Again, both of these powers have the same base. And because I'm dividing, I'm going to subtract that exponent. So essentially, I have 7 to the power of negative 2 over 3 plus 1/2 minus 1 over 6. We need to do this math. We're going to do it off to the side because it is fraction addition and subtraction. So negative 2 over 3 plus 1 over 2 minus 1 over 6. Here, I'm trying to add and subtract fractions, which I know requires a common denominator. The common denominator here is just 6. So I need to rewrite all of these as fractions with a denominator of 6. So here, to go from 3 to 6, I need to multiply the numerator and denominator by 2. So 3 times 2 is 6, and 2 times 2 is 4. I'll keep the negative because it's there. Here, I want to go from 2 to 6, so I need to multiply both the numerator and denominator by 3. So 1 times 3 is 3, and 2 times 3 is 6. Because there's a positive there, I'm going to copy the positive. And here, the denominator is already 6, so I'm going to keep it as is. Copy the negative because it's there. Now, when I solve this, I keep the denominator. Negative 4 plus 3 is negative 1, and negative 1 is negative 2. If you can simplify, continue simplifying. Here, I can divide both of these by 2. So 2 divided by 2 is 1, and 6 divided by 2 is 3. So I'm left with negative 1 over 3. So here I can rewrite this as 7 to the power of all of this equals negative 1 over 3. Keep in mind, I didn't want to leave my answer like this because it says find a single power with positive exponents. You never leave final answers with negative exponents. So whenever I have a positive exponent, I can convert it by changing it so that I have a fraction where the numerator is 1 and the denominator is just this, but instead of a negative exponent, I have a positive exponent instead. Okay, so that's what we do there. Let's take a look at this question here. Here we have 27 to the power of negative 1/3, all to the power of 4, and all of that to the power of negative half. So what we're trying to do here is we're trying to simplify and express everything as a single power. Okay, so here we have a power being raised to a power, and that's being raised to a power. So we can just multiply out these exponents to write it as a single power. But we should also, to write it as a single power, and that's essentially what we're going to do. So here, let's just take a look at this first. So we have 27. We have negative 1 over 3 times 4, which is negative 4 over 3, all to the power of negative half. We still have a power being raised to an exponent. So I'm going to keep the base and multiply out the exponents. So let me do this on the side. Negative 4 over 3 times negative half. I can reduce this. I can divide this and this by 2. So 2 divided by 2 is 1. And 4 divided by 2 is 2. So I have negative 2 times negative 1, positive 2, divided by 3 times 1, which is 3. So 27 to the power of 2/3. If this question had asked me to evaluate, again, I could have simplified this, I could have evaluated this and gotten a final answer, but that's not what the question asked. The question simply asked, write each expression as a single power with positive exponents. These are both single powers with positive exponents. That's all we were expected to do here. Let's keep going. It says, write each expression as a single radical. I know I didn't mention the word single there, but that's essentially what I mean. So all of this needs to be rewritten as a single radical. So let's try that. Here we have two powers, and we know we can rewrite each power as a radical if it follows the particular rules. But we want a single radical, so let's convert this to a single power first. So here we have two powers being multiplied. They're being multiplied, so what we're going to do is we're going to keep the base and add the exponents. So negative 5 over 6 plus 2. Again, let's do that off to the side. So we have negative 5 over 6 plus 2, which is the same thing as 2 over 1. We're trying to add fractions, so we need a common denominator. The common denominator will be 6, so I need to multiply the top and bottom here by 6. So I'm left with negative 5 over 6 plus 12 over 6, which is just 7 over 6. So in this case, I'm left with 3 to the power of 7 over 6. Now we need to rewrite this as a as a single radical, and that's what we want to do. So when we're evaluating, I said we should always move over the numerator. When we're writing as a single radical, unfortunately, it's the opposite. We're going to move over the entire denominator. So in this case, we can rewrite this as 3 to the power of 7 to the power of 1/6. So again, in these questions, when they ask you to evaluate or solve, you're always moving over the numerator. If they simply want it written down as a single radical, you're moving over the denominator. Why? Because now we have a base to the power of 1 over something. We know that the base goes inside or underneath the radical, and the n value becomes our index. So we can rewrite it like this. Let's move on to this question. So again, we're rewriting it as a single radical. 5 to the 4 divided by 5 to the power of 3 over 4. We have two powers being divided, which means I'm going to copy the base and subtract the exponents. So 4 minus 3 over 4. Again, we're going to work out the fraction work on the side. So 4 minus 3 over 4. Remember, the 4 is just 4 over 1. Again, we have fractions, and we're subtracting them, so we need a common denominator. So I'll have 16 over 4 minus 3 over 4, which is equal to 13 over 4. So I can rewrite this as 5 to the power of 13 over 4. Again, if this had said solve, I want you to move the numerator over. But whenever you're writing it as a single radical, you're moving the denominator over. So this is the same thing as 5 to the 13 to the power of 1/4. Again, 13 times 1/4 gives me 13 over 4, so we know this is correct. And when we have it in this form, base to the power of 1 over n, we can rewrite it because the base becomes the value underneath the radical, and the n value becomes my index. The last question here, write each expression as a single power with positive exponents. Again, we're just using the power laws here. There's nothing to solve because the bases are variables here. So here we have multiple powers being multiplied. Here we have a to the power of 1 times a to the power of negative 5 over 3 times a to the power of 1/3. So when we're multiplying powers, we keep the base and add the exponent. So 1 minus 5 over 6 plus 1 over 3. And we're going to do the fraction work on the side again. So 1 minus 5 over 6 plus 1 over 3. We're adding fractions. We need a common denominator of 6. So this is just 6 over 6 because I'll multiply both of these by 6. This will be negative 5 over 6. It already has a denominator of 6. And to get to 6, I'm going to multiply the numerator and denominator by 2 here. So 2 over 6. So I'm left with 6 minus 5, 1 plus 2, 3 over 6, which ultimately reduces to half. So I can replace this with a to the power of half. Always check your instructions. It's a single power now with positive exponents. It's good. Let's take a look here. I have x to the power of 4 times x to the power of negative half divided by x to the power of negative 3, all to the power of 1/3. So again, the top here, I have two powers being multiplied. So I'm going to rewrite it as the base to the power of the exponents being added with one another. So 1/4 plus negative 1/2 gives me 1/4 minus 1/2. And at the bottom here, I have x to the power of negative 3 to the power of 1/3. So essentially what I have is a power being raised to an exponent. So I multiply the exponents. Negative 3 times 1 over 3. So negative 3 times 1 over 3. Essentially, these cross out to give me 1 and 1. So that gives me negative 1. So I'm left with negative 1 here. Now I have two powers being divided. So when powers are being divided with the same base, I subtract the exponents. So I have x to the power of 1/4 minus 1/2. So that's the first power minus the exponent down here. So minus minus 1. Again, don't forget that this minus represents the division. This exponent just happens to come with another minus. So I can add these, and I'm left with x to the power of 1/4 minus half plus 1. Again, I have fraction work to deal with here. I'm going to do it off to the side. So 1/4 minus 1/2 plus 1. Again, that's the same thing as 1 over 1. I need a common denominator, which is 4. So 1/4 minus 2/4, I multiply both by 2, plus 4/4, I multiply both by 4, which gives me 1 minus 2 is negative 1, plus 4, 3 over 4. Okay, so 3 over 4. And what that leaves me with is x to the power of 3/4. Again, I have a single power with positive exponents, so I know I'm correct. This will be the homework. Make sure you hand it in on our Google Classroom. Thank you.